Hi everyone, this video is going to center on an application problem from the Chapter 5 material on fractions. So let's go ahead and just dive right in. Carol has a poster board that is 3 1/3 feet long that she's going to use for an art project. She needs to cut the poster board so that each new piece is 5/6 of a foot long. How many pieces will she have? So maybe what we might want to do to start is to think about strategy. Maybe outline what information I have, maybe represent this in a picture. So I'm going to go ahead and just put my poster board in here as best as I can. And most of us are probably pretty adept at drawing a rectangle or something that resembles one pretty closely. I'm also going to label this. So I am going to say or note that the length of this poster board is 3 1/3 feet long. Notice that this problem does not give you the width or the height, I guess you could say, of the poster board. So we either need to ask ourselves, do I really need that information, or is it extraneous, I guess would be the appropriate term, or in other words, is it extra info that I don't need? So I'm going to go ahead and read through this one more time to really see if I have all the information contained within this narrative. So Carol has a poster board that is 3 1/3 feet long. So I got that picture already drawn and labeled. She needs to cut the poster board so that each new piece is 5/6 of a foot long. So why don't we go ahead and model that? So let's just assume, again, this doesn't have to be accurate, this is just a picture that we're drawing and playing around with. So say she's going to cut one of these strips, and that strip is going to be 5/6 of a foot long. And then she's going to continue to do that, creating another strip that is 5/6 long, and another, and another, and so on. I don't know if my picture is accurate yet. So again, we're just kind of playing around with this. But what I'm noting here is that the narrative does say something about cut. So I'm taking something that we could consider a whole, so this whole poster board, and I'm going to cut it into pieces. Or in other words, I'm going to, instead of cutting, we could say I'm going to divide it into pieces. So this might be the best approach. I think, based off of the wording and based off of the image that I've created, that I have a division problem. So what I want to do here, in general, when we're laying this out, is I'm going to take my whole value, so I'm going to kind of explain this or map this out in words, and I'm going to divide it by the desired parts. In other words, I'm saying I want to take my 3 1/3 and I'm going to divide it into parts of size 5/6. So I chose to add a couple layers of challenge to this problem, mostly to touch on aspects of review for you so that you don't think that all the things that we were learning previously are self-contained or compartmentalized. You want to break them out of those boxes and try to make those connections. So one of the first things that I'm going to want to do is, in order to do this division properly, if I'm going to use our division algorithm, I'm going to rewrite my mixed number into an improper fraction. So if you recall, in order to do this, I'm going to take my denominator times my whole value and multiply, and then that's going to give me 9, and then I'm going to take that result and add it with the value in the numerator. So 3 1/3 turns into 10/3. So now that I've done this, my division problem is all set up, and I should be able to kind of easily go through my algorithm in order to approach this. So if you recall from class, I had informed you that in order to do this, kind of the shorthand or like the little trick is to skip it, flip it, and once that's all done, multiply. So what is this going to result in? So this result is going to be, I'm going to skip the 10/3. In other words, I'm just going to leave it as I see it. I'm going to flip the 5/6, or in other words, take its reciprocal to get 6/5. And as a result, that's going to give me a multiplication. So now I'm all set. And again, at this point, we could go ahead and just multiply straight across with the numerators and multiply straight across with the denominators, and then reduce. That was one of the ways that some of you had pointed out in class. What I want to note here is that I could take care of the reducing early. So take a look, for example, at our 6 in the numerator and a 3 in the denominator. That tells me that I can reduce them. So I could cross-cancel, and I could reduce each one by 3, so that would leave me with a 1 in the denominator and a 2 in the numerator. And again, we also want to check over here, so take a look at the 10 and the 5. I would also say in this case, well, I could reduce them. So I could reduce them by 5 in this case. That would leave me a 1 in the denominator and a 2 in the numerator. Once this is done, we'll go ahead and we will multiply. So 2 times 2 is 4, and then 1 times 1 is 1. Or we could just say it's simply 4. She is going to have, so Carol will have 4 pieces after she's done cutting. So as you can see, to kind of illustrate, if you go back to my sketch, I was not correct in terms of doing my rough sketch, but I really wasn't shooting for accuracy. I was just doing this in order to illustrate the point, or to kind of help me arrive at the conclusion that this is a division problem. So I hope that this explanation was okay. If you do have any questions, please feel free to message me on WAMAT.